those online we have a couple of persons online also, and there might be others also connecting during the day for certain presentations. And we will also record the sessions and see how we can share them. But I think for the discussions, we only share the presentations, not the discussions. I'm talking here a little bit to wait for the last few persons coming into the room. Okay, no? They're not coming into the room. Okay. They didn't want to be here. Okay. So I don't know, something. Okay, let's go. So it's really great to have you here. Welcome to Stockholm, to KTH, and to the 8th International System Dynamics T-SIG workshop. It's a quite long name of this workshop, but I'm really excited to have you all here. Looking forward for 2 days here of a lot of conversations, dialogues, presentations, and fun, which I hope we will have. So I'm Anna Palmestål, and I'm working here as a researcher at KTH, within sustainable transport. But without this talk is not about me. So let's go here. We have. I will first do a bit of like practical details before we open formally open the session or this conference. We will, as I said, we will do some recordings during the presentations. If you are a presenter and don't want your presentation recording spread, please let us know. We have the program. It's also on the door. We have a few copies printed out if you would like to have a look at it. But you can also just go with the flow. We are up here. Obviously, you managed to get here, all of you. So that's good. Tomorrow we will also be in this somewhere here. But we will come here also tomorrow and start here, and then we move together. It could be nice to know that this area of the campus is sometimes called Brazil because it's kind of so far away from everything. But we do have a very nice forest, and we might take a lunch walk out in the forest. So a few practical things. We have the KTH team, which will help us. We have Zainab, Bavna, and Vivek, and Simon, who has raised his hand. And Anita, yeah, sorry, you're the door opener, sorry. So if you have any questions or so, just ask those guys. They know exactly what will happen and how to handle things. We also we have the emergency exits. You can go in that direction. You can go down the stairs where we came from. So those are the emergency exits. If something happens, which will not happen. There are also toilets just behind the kitchen there. And there is a coffee machine outside, and we will also get like other coffee, more coffee, proper coffee later. We will be served food, so we will have lunch today and tomorrow, thanks to the System Dynamics Society, and we will have dinner tonight, thanks to ITRL Integrated Transport Research Lab, which we will also visit tomorrow. So you will learn more about that. Jonas is over there, and Andres, they are director and co-director of ITRL, so happy to have you here. So you'll see that tomorrow. And thanks a lot for making this possible and making it free of charge with the food. Yes. The door. You have noticed that there are two locked doors between us and the outside, maybe. So if you go outside and don't get in again, there is a phone number that you can call on the signs, or you can write in the WhatsApp group, and we will keep an eye on that. So it's locked both here and downstairs, and that's a campus policy that we cannot do anything about. So don't panic if you get out. The dinner tonight, we will tell by the end of the day. We will also show the address for the dinner. For those of you who have signed up for that. Anything else we should say about the dinner right now?
No, but I mean, if you want, we could also walk together to the place.
Hmm?
So if you're up for that, bearing the cold.
It's a few kilometers walk, so it's probably nice. And then we have for those who want to do, we have a small hike on Saturday, which will be primarily led by Vivek and Simon, but we'll tell more about that later on. Or do you have something you would like to say about that already now?
No, we can take it later.
We take it later. Cool. So I guess that was it. That was the practical details. Have I forgot something? Good. And then I would just like to close my part of this opening session by saying that we this year is the first time that we do this full paper presentation, where we also have a discussant for those presentations, and we also with those sessions we also have plenty of time for questions and the dialogue among us. So I really would like to ask you to be active in the dialogues, ask the questions. There are really no stupid questions, because system thinking is complex and difficult, and we cannot do it by just sitting at our own desks, not talking to others. So take not only for those sessions, but for the whole workshops. That's my wish to you, to actively participate in the dialogues and the discussions. And that's also the reason why we have put you in this shape, because we think it's nice way to also see each other's faces and to participate in the dialogues. And due to that, we will also, I suggest that when you go out and come in again, that you take another spot, because those who sit here will have the neck pain and those who sit here. So you understand, okay? So with that, I hand over to Simon for a small introduction from the T-SIG committee.
Thanks, Sarah. Hi, welcome everybody. My name's Simon Shepherd. I think if you were in Vienna last year, you saw me do a presentation about how my interest in system dynamics began, etc. I suppose I'm one of the people who's responsible for you all being here. Way back 10 years ago, I think it was, myself and Enzo Bivono sat on a bus at the International System Dynamics Society, where there was no thread on transport, so we decided to set up a special interest group, which seemed reasonable because we were sat on a bus. And being from Yorkshire, I said it has to be free, because if nobody else will come, because transport's very small. So we've kept on that tradition, and we think this is the eighth conference now. We're interrupted by COVID, a bit of online, all that. So it's good to see so many people here in person, lots of new faces, lots of original faces as well.
I came later.
So yeah, it's great, and systems thinking is what we're all about. And it just made me think of a comment that a colleague said once when he was doing a study about road pricing and people's responses to road pricing. And he interviewed somebody and they said, "What will you do?" He said, "I'll make my own sandwiches." So yeah, you've got to think of more systems than the actual traditional economists or whatever might think of either. So it's always good to get together. We've got a great programme here. As you say, we're trialling this full paper version with discussants. I don't know how that will go. Any feedback on that? Always welcome. And so we'll get on with the first session, I suppose, which you've just asked me to chair. So the first person is Joan. Welcome, Joan. And you're going to do something about Back to the Future, which is also my favourite film. So So you've got 25 minutes to present, and then Anna's going to respond for 10 minutes, and then there's time for questions as well. So you're our guinea pig.
Thank you. Good morning, everyone. Thank you for having us here and giving us the opportunity to present. And also apologies for the change of schedule. We were supposed to present tomorrow, but because of the agenda of some of us, then
Sorry,
we had to.
we need to stand near
Yes.
the computer.
Okay.
Yeah, sorry.
So my name is Juan Pablo Castrellón, and I'm here with one of the co-authors of the paper, Sarah Rogerson. We are from RISE, the Research Institutes of Sweden. We are sitting in Gothenburg at the Maritime Department, and we are part of the logistics unit there. We do research in freight transport in different contexts, urban freight, in ports, and now we will present a research about inland water transport. And that was one of the motivation for the title, which is Back to the Future, given that inland water transport was one of the main modes of transport in the past. Now is a little bit forgotten, almost irrelevant in some figures in some countries. The study is about how to understand the uptake of this mode of transport in Northwestern Europe. So I will address this agenda in the 25 minutes, or maybe less, so we have more time for discussion. Presenting initially a motivation, the context of a study, then I will introduce the research aim and the design of the research, then some results and conclusions. And as I said before, it's back to the future because, water transport or inland water transport was predominant in the up until the 20th century. And only in the last part of the 20th century, the share of ton kilometers moved by inland water transport dropped by almost 12% or around 12% in the European context. Today it represents more or less 2% of the total flows in ton kilometers, and definitely with a decreasing trend over the years, the last at least 10 years. Here are some pictures of how the cities even look, not only inland water like in the national context, but also local context, like with the canals, with the rivers. The main rivers in Europe as well were used for freight movements, and today again is not significant. However, it has received the attention in the decarbonization agenda because of the benefits in reducing carbon emissions of transport, also the technologies that have been developed, the economies of scale that it can generate, and aspects in urban areas, for instance, like reducing congestion, like moving trucks out, moving them out from the streets and moving the freight on the waterways or canals. And there is actually an ambitious target by the European Commission to increase the inland water transport volumes by 25% by 2030 and by 50% by 2050. That's the target. However, this is the trend again. In the last, and this is with respect to 2015. So as of now, what has happened is that instead of increasing that much for this goal, it decreased 15% between 2015 and 2024. So there is a challenge, and where to look at if we want to revert that challenge. So definitely there are countries in North European context that traditionally have been using waterways for freight transport. Mostly France, Germany, the Netherlands, Belgium. Those countries account for 80% of the ton kilometers moved in Europe in waterways, in inland water ways. And Sweden, although it's not, it doesn't have a significant participation, and in the context of Sweden, is only 3% of the flows that move through water, but was the country in Europe with the highest increase rate between 2023 and 2024. So the potential is there. Some goods are moving there. Some corridors are already there. Ports, quays are there or need to be developed. So apparently there are different aspects, but there is something that is still not working, and we wanted to analyze that. Because if we see, okay, I talk about infrastructure, I talk about the demand, the goods movement, but also the technology about the vessels. We work at RISE, and before it was SSPA, a specialist in the design of ships and vessels with different technologies. And we have seen also in different contexts how, for instance, cleaner energy sources for vessels like electric vessels or LNG propelled, robots for loading and unloading and the automation of loading and unloading processes, the vacuum mooring, so the approach to the quay or to the port is in an automated way. Also autonomous sailing. So there are solutions that definitely are meant to decarbonize transport and make it more efficient, and maybe reduce the barriers that before the inland water transport had, like inefficiency in the operation, not green, and the lack of use of green energies and so on. Despite those advances, research has pointed at aspects that need to be addressed, so we revert that trend. Those aspects are related to the business models, so something has to be addressed in the way that companies make decisions, interact with each other, the service provision and design. Organizational behavior, how the different stakeholders make decisions to shift from road to waterways. Sometimes, and this is a research that has been done, from a long time, led by Sarah, where I understood how managers were deciding on going by road or by water. And sometimes there is this road transport inertia, as we call it in the paper, that is the easiest way, is the quickest way. It's the way that doesn't need that much planning in advance. No? So there are behaviors at the organizational level that need to be understood. And of course the technology is there, but also here is who steps first with the adoption of the technology, the risk that implies, who will invest, who will pay extra for cleaner technologies. So the technology is there, but there are still aspects to be analyzed. And on top of that, there are nuances among countries, so what works in one country maybe is not, even if we are talking only about Europe. So there are nuances among countries, among commodity types. It's not the same, or there are challenges or different challenges if you are moving containers, or bulk cargo, or ro-ro, so there are different aspects to be considered, and also acknowledging the different forms of operations, of inland water operations. It's different to talk about urban transport, or regional transport at the national level, or short sea transport, for instance, or coastal sea. All of them could be framed in this concept of course, water transport, waterborne transport. So that's the motivation of the research. And now let's talk about the context. I joined this project recently, from 5 months ago. That's why you see that my breathing is not smooth. So I'm learning still, because my background is more in urban freight. But it was an amazing project that is led by Sarah in RISE, but it's in collaboration with different organizations in Europe, in these countries. And maybe someone could tell, okay, why did you compare Germany and Sweden? I mean, the proportion of goods is completely different. But this project allowed us to go with those that are introducing innovations in their context. So these countries were introducing changes or innovation in the way that water transport was performed, even if it was in urban areas, or trying with new goods, or trying with new vessels or new technologies. So all of them were pilots, innovation pilots, that were introducing a new way to move goods in inland waterways. It was funded by Interreg and the Ministry of Energy, or the Department of Energy of Sweden. My Swedish is not good, so that's why I don't try to pronounce the name. Research, design, aim and design. So the purpose of our research is to examine the uptake of inland water transport for freight in this context in Northwestern Europe by analyzing interactions across business models, technologies, and behaviors. So we saw that these components were pointed out as important aspects to analyze. They were analyzed separately in papers, as were referenced before, and we wanted, and as the promise of the project was to have a system perspective, so how to put together these elements and understand how they interact with each other to generate the uptake of inland water transport. So with that, if the promise of the project was also system perspective, so what the first question was, what's the system? No? How we understand the system. And we have a famous reference for the definition of the system in transport context, made by Wandel. I think this year is not correct, it's 1992. And then we have, sorry for that. And then we have a system with multiple layers that interact with each other through interfaces. So we have the supply chain layer with all the receivers, shippers are interacting and making deals for like buying or purchasing services and goods. Then we have the transport layer, where the technical aspects of the transport services is there, where to go, what route to take, and so on. The infrastructure layer is where that transport happens, right? So what are the keys or the ports available, the roads or the waterways in this case, and so on. And there are interfaces, for instance, between the supply chain layer and the transport layer. Of course, here there is an interface called transport service market, so where all the service providers are there and enable these actors to really have the transportation service with the solutions that they provide and so on. And between the transport layer and the infrastructure layer, there is a traffic layer, which is the actual movement and the use of the infrastructure, where to park or where to approach or unload and unload at the destination or at the region. So that was the system definition, and that helped us to identify the variables of each component. That later on we will connect through a system, through a causal loop diagram. So we use the system dynamics approach to connect those variables. We are not experiencing the use of this tool, so that's why we were happy to hear that this workshop was happening, to test and validate what we were doing. And I had some background on the tool, but not actually doing research with the approach. So we wanted to answer this question: which systemic leverage points, and this was a concept that we learned through the process of the research, those points that are or potentially can generate system-wide effect if you make interventions on them, most influence the adoption and scaling of interwater transport for freight in Northwestern Europe. So that's the research question. And then why or how did we conduct this? When I joined the project, so Sarah had performed all the interviews during the past 2 years or 3 years. Almost 19 interviews, semi-structured interviews, with shippers, transport operators, public authorities, forwarders, ports, related to the uptake of inland water transport. So my job and our job later on was coding those interviews based on this structure, based on these categories. And internally at RISE, we connect the variables. We analyze how the directionality work for each pair, and then build the causal loop diagram. That later on was validated with the members of the consortium of the project in the water. That way they were like giving feedback if the relationships that we established were correct or not, and also gave us insights which ones they considered were the leverage points. So that was the data collection. So now let's jump into the results, and maybe to prepare a little bit the discussion, we were curious about how to present this, because it's, sometimes the model is only understood by the one that draw it. So we will see how it goes and how to communicate, not only in presentations but also in paper. So we want to learn about that as well. So this was the list of variables that we identified at each of the system components. So as I said, in supply chain layer, so we saw that there were aspects related to the number of stakeholders, the organizational capabilities of they have the knowledge how to make the decision of the modal choice, the tools that they were using, the complexity of those relationships, the engagement, communication, and so on. And important aspects related to the production and the storage capacity, because this is what also influenced the road transport inertia. Because if you wait for the vessel to come, of course it's bigger, so you have to plan ahead how much to produce, how much capacity you have to store to be able to later on load it on the ship and so on. The transport layer is mostly about the operation itself, service level, the energy usage, and what we call maybe the key variable, the decision variables of our model, that at the end is the shifted volume. Later on, if we want to develop this model further and with all these stocks and flows diagram, maybe these are the stocks that we will check, the shifted volume and the performance variable will be the cost of inland water transport. But shifted volume at the end is the main purpose. No? Here we have also aspects related to the vessels, the handling, the loading and unloading, and the specialization of the actors in handling different type of cargo. The infrastructure layer, this is where we have the ports, the quays, the complexity in investments in those infrastructures, if they are public owned or private owned, how they are considering the inland water transport or only for sea transport or long distances and so on. The market, so how the contracts are negotiated, for how long, and this is one of the critical parts, because if you want to adopt new technologies and so on, you need a security, a certainty on the contract that you have. So long-term contracts, but what we saw in the industry was the opposite. The transport, at the end, we are competing with other modes, but as some of the members of the coalitions of the project, to say maybe it's not competition, because at the end we need first leg and last leg of the entire trip by land. So it's also how to promote the cooperation, and this is more about how to think of the business model as a whole. The incentives, and definitely there is a political will. This in the agenda, in the development of for the transport decarbonization. So there are incentives, but still there are regulations that are not aligned with what we want. In terms of access, in terms of traffic, in terms of the technology that needs to be used, and so on. And the traffic interface is where the interaction with the infrastructure, no? And this is, for instance, an aspect related to acceptability, how others perceive the inland water transport. If we are in the urban area, so maybe some people prefer the tourist boat instead of seeing containers or boxes, or in the quay for loading and unloading, they prefer to have restaurants instead of an area where you can load and unload. Or there are other activities also happening on the rivers, like sports as well, like other type of operations that could enter in conflict with the operation. Safety, risk, collisions of vessels with infrastructure, and so on. So this overall are the variables. And this is where I say this is the difficult part. So I will not go into the details, but this is how it looks. We use the CLD tool. There is online tool for drawing the causal loop diagrams. It's generated by the University of Applied Science in Switzerland. And we connected the variables here and with a color theme based on the layer of the system that they belong to. So if it's red, it's the supply chain layer. If it's this Levanter, is like the transport layer, the transport layer, then the traffic layer, the infrastructure layer there in black. And we identified 5 reinforcement loops and 2 balancing loops. We use these loops for making the comparison between countries, between type of freight, and between forms of inland water transport. So we saw what happened with the inland water transport procurement. What are the variables that are like influencing this procurement? Like for instance, what I mentioned, the production and the storage capacity, right? The organizational capabilities that are in place for purchasing the services. This road transport inertia that I mentioned before. The volumes uncertainty, so how to avoid these empty trips because they have certainty of going but not back. So how this cycle works for the different types of goods and countries and so on in the procurement of the service. In the negotiation of the contracts also, what are the aspects that are or the variables that are influencing this feedback, and then we have the negotiation power. Who has the negotiation power? How to influence longer term contracts, and definitely service level is one of those variables that, okay, if the provider can be certain about the frequency, about the time that they will be there, for sure they can exert some power at least, or promise some service levels. But what we saw is that sometimes it's not possible because times could be longer, and then companies shift to road transport. So aspects about flexibility of the requirements as well. And of course, everything ends up in cost. So how much is the service, and if they are willing to pay more sometimes than other modes. Then efficiency, the feedback loop in efficiency, which is influenced also by service level, but also by the equipment that they use, the technology that are there. Definitely is a field where we have all vessels as well, not that efficient, but also the introduction of new ones with the promise of being more efficient, faster, and able to navigate in shallow waters in canals, in cities, and so on. And finally, the environmental aspect, that is the promise of inland water transport, how it reduces the environmental emissions. But it's also connected, of course, with acceptability. So it can have high acceptability if the emissions are reduced, but maybe if we increase in a significant level the operations, maybe there will be other aspects related to conflicts in the use of infrastructure, congestion. But this is in all the transport modes. So at some point it needs kind of an equilibrium. Then balancing loops related to the saturation of transport infrastructure, as I mentioned, the conflicts that they could be with other users as well, the integration with other modes of transport, and finally, the balancing loop regarding infrastructure. And this is mostly about who is going to invest and how the actors will coordinate for the investment. The key could belong to the municipality, but it's the private actor that is operating, so who is able to use the service, who will do maintenance of the keys, and so on. Is profitable for the operator, maybe it's not that much, they are focused on ports, and so on. So these aspects are related to the infrastructure. So this is the general explanation. In the paper we explain cycle by cycle in this way, so I will not go into the details, so we have time for the discussion. And the main point was to arrive to the identification of these leverage points. So we have this map of variables, a lot of things happening there. What are the leverage points? Where to focus if we want to have system-wide effects? And we identified these three variables. as leverage points based on the knowledge of the team. In the team at Rice, we have not only researchers, but also practitioners that have been in the industry and are co-authors of the paper, so they were giving their feedback on that, and also the members of the project of InnoWater. And then the three leverage points are these ones: organizational capabilities that are related to these variables about business models and behaviors that shippers and carriers have to plan, negotiate, procure the inland water service, and to have this match between production, storage, and transport. Then the maturity of inland water usage, because it's not, and it involves the infrastructure there, the availability of the infrastructure, the use of that infrastructure, but also it implies that the maturity in the experience that the actors have in using waterways, and how they know the pace of the volumes, of the frequencies, and of course the coordination with the different actors and experience in that coordination. And finally, the acceptability, and this is an acceptability that is internally at the company level or the supply chain level, to accept that this kind of service could provide some service levels, and then adapt to those service levels, but also the acceptability of the community in urban areas, in regional, in national context. So being aware that there are ships passing by, and the effect that could have on the acceptability of those operations. So as I said before, so we use the feedback and the feedback loops for making the comparison among the countries. I will not go into the details. And we use the leverage points to identify actions and practical implications, what to do regarding those, and create the system-wide effects. So about organizational capabilities, what we found like a critical or intervention to do is the promotion of long-term contracts, and this is how to build trust, and also like a fair like contractual terms for service providers, but also for shippers and customers as well. And this could be leveraged or also supported by digital platforms. Like in Sweden, there is a development on that, where you can test, you can see how much it is, you can have different options to do that. So you also train the shippers in making those decisions. And then here there is a type of supply-demand matching under efficiency conditions. Training of logistics planners, as I say, and aligned sustainability goals with transport procurement. There is not only cost what matters, but also how sustainability could be put into the equation. Then the maturity of the system, and then here we have how to define the investment in the infrastructure, the coordination among the different stakeholders, the governance that should be around the inland water transport. And also, of course, the interaction with digital technologies, now that we have more availability of tools also for vessels, but also to interact with the infrastructure. And finally, the acceptability, and this is how to generate incentives for actors using this service, but also how to engage the community, how to communicate the benefits of the service, and so on. And of course, there are like countries or contexts that we saw that maybe are or could focus more on one or another leverage point. For instance, in Sweden, the development of organizational capabilities, and how actors that have been used the service before, but they don't do it anymore for any reason. So they are used to that, how to develop capabilities so they can go back to those practices. Or for instance, in countries like Germany and the Netherlands, where the system is mature, but maybe now the concern is how to diversify, and not only, for instance, coal transport, but also include other commodities, also container transport, or transport in urban areas. And acceptability, for instance, in Belgium and France, they have also mature system, but maybe now the challenge is how to reach the cities. In canals that are there, but now they have different uses, so how to also build this momentum inside the urban areas. By commodity type as well, so bulk and container transport, maybe a big need in organizational capabilities, in the maturity and acceptability in raw aspects, because, for instance, they use port infrastructure. So this is how to manage the space also for this kind of operations in port areas. I think that I am run out of time, or we are. Yeah, I have. Okay, I have just one last slide, but we have also here for the different types of transport. And then I will jump to the conclusion. So with this research, we wanted to identify the reinforcing and balancing feedback loops, associate and identify these leverage points, integrating business models, technology, and behavioral factors in the system. Also compare the context that we had at hand, context the different types of goods and the different type of forms, and also providing like relevant insights or insights that policymakers can take into consideration, but also companies in the decision of transport modes. With that, we understood what variables affected the system. Now the problem is quantify them, how to collect that data. Maybe there's a future research how to quantify and the effects also of the different interventions on the leverage points. But yeah, we are looking forward to the discussion and the feedback. And thank you very much. Here are some pictures shared by Sarah from the demonstrations in the different countries. So thank you very much.
Thank you.
I guess we invite Aaron now to discuss.
Yeah. Thanks. Very nice.
Do you want to sit here?
Yeah, please. So, yeah, write down any question you have, and we will have time for that also. So I got the opportunity to read, the pleasure to read the paper. It was really nice paper, and for me a new application. So I will do this presentation, or I read the paper through the lens of a person working with like upscaling of road freight, electric road freight transport. So that might bias my view of the paper a bit. But yeah, it was a real nice read. Yeah, let's go. So some things I like to just highlight a few of the things. So here is also one picture of this Wandel model, which is familiar for us. I will come back to that. I will come back to that later, but we are very familiar with that, Zainab and I. But yeah, I think it was a very interesting topic. It was, of course, Back to the Future. Who doesn't get interested in that paper? But I think you have really a point there, that it is something that we have used and then went away from, and then question is, how can we get back to this? I mean, we are in Sweden, and the Vikings did inland water transport. That's why we are here. Actually, so it's super, relevant topic, especially for this place. I think it's amazing you have done 19 interviews with people from 5 countries. So it's really a broad data collection for the work. As I said, I like this combining with a 3-layer Wandel model and system dynamics. So we'll come back on that. And I read the paper that you did the interviews, if I understood right. You did the interviews, you had the material, and then you used system dynamics and causal loop, the causal loop mapping to kind of get make sense from what you have found. And I can clearly also recognize that feeling, that you sit there with a lot of information and how do I get structure in this. And I think, yeah, obviously we're here, so I think causal loop diagram is a nice way to do that. And I think in the paper you presented it together with quotes from the interviews, which I also think was a very nice, you could really relate the responses from the interviews to the CLD. To continue, I think I also got some questions when I was reading the paper. So I think you could have said more about the interviews and the interviewees. Who are they? Big companies, small companies, how many from the different countries? What questions did you ask? I was curious about that. And you did, if I understood right, you did the interviews from all the interviewees are from pilots or people who would like to adopt or try working with pilots of inland water transport. Maybe you have a bit of bias there. Maybe it would be good to also know what the people who are already using inland water transport do, and maybe it's also good to talk with people who does not want to use inland water transport. And I think this is also something that I've been thinking about when we are working with electrified transport. We tend to work with the ones that are kind of early adopters, and that will give us an understanding on how the early adopters act, but all the others. And to have a bigger large-scale adoption, we need to also target the others. But that's So that could be something also for us. I'm looking at Vivek and Zainab now especially.
And if I can add to that, having done a lot of interviews, maybe we can definitely take on board that we need to describe the interviews and who we've interviewed a bit clearer. Because we were doing interviews outside of the pilots as well, but maybe it's not. I understand now that it's not clear in the paper. I think that's a really good point. And that way, I will also give you time to respond to the question. No, it's good that we need to have but I put a lot of questions here, so I don't know really how to do this, but maybe it's good that you respond actually. Now. Sorry if I went away from the format.
No. I am sorry for me for interrupting or destroying a nice format coming up here.
Very useful comments.
But I think it also holds for all of us working with adoption of different things, that we tend to work with the kind of the early adopters. And I'm not sure, or I guess research from other fields tells us that the early adopters have a different mindset compared to also the early majority or the late majority. And so I think that might be something for all of us to think about. Yes, so a few comments about this, about the Vandel model. So together with Zainab, mostly driven by Zainab, we did similar work using the Vandel model to structure insights about how our question was a little bit different. We asked ourselves here, so what are the system level impacts of electrification of road transport using this Vandel model, and we ended up with the same thing. We started with different workshops, and we ended up with a mess of a lot of good insights, but really a mess. And then we could use the Vandel model to structure the ideas. What we did here was also to use the Vandel model to visualize where the influence would come. So here we have the direct effects. It's pretty bad here, but the red ones are where we thought, okay, the direct effects, the electrification of freight would change the refueling time. But that would then like have indirect effects that spread through the whole system. So yeah, just an example, and maybe it could be good to discuss this a little bit more, how we can use this model to structure our thoughts, and maybe you can even make in your paper, maybe you can make it more visible also with the Vandel model. You have it with the colors that we saw in the CLD, but it might be useful to also visualize in the model where you have your leverage points. Which layer are the leverage points in? Can you use the model more? And yeah, then I asked myself then, are there maybe similarities with the electric truck adoption? I saw this. So now I did really simplification of your CLD here. So we have some kind of inland water transport adoption, more adoption, less access to infrastructure because it gets congested, and then which will influence the attractiveness of inland water transport, which will influence the adoption. So this is basically congested ports, maybe. But on the other hand, you pointed out this infrastructure development. So if there is a limited access to infrastructure, that will increase the pressure to invest in new infrastructure, which will reduce that. Or then increase the access to infrastructure. And you also pointed out, I think, this some kind of learning by doing loop I found. Adoption of inland water transport, which will increase the knowledge, which will increase the attractiveness, under the assumption that if you learn how to use it, you will find it more attractive. But then we had the competition then with other modes, which they need to be compared with. And to me, this is very similar to I can just kind of replace inland water transport with e-trucks here, and that made me think. Yeah, that I think I don't know if maybe you talked about this 10 years ago, also on the bus, but I think this adoption of new technologies is something that several of us in this room share, and maybe we can find some through zooming out a bit and looking at similarities and dissimilarities. I think we can learn more from each other and eventually do some more general work here. And of course, I think it was very interesting also that you pointed out the longer contracts, because that's also something that we have been discussing with trucks, and something that limits the e-truck adoption. The contract length seems to be is short and limiting adoption. So a very clear similarity. So, but I think that was my e-truck lens on this. And thank you very much for a nice read.
Thank you for the comments, and this is very interesting. If we can access the slides.
Yeah, sure, share, of course. So I have some notes also for you, which I will of course share. But thank you very much.
Thank you.
So now you swap places again, I guess.
Maybe, or maybe we are all here, because I think now we have time for questions or more dialogue or so. If you have any, I have more questions for you.
You just had your turn. Go on.
Go on, thanks. yeah, I was curious. Why did you choose the Vandal model?
Yes, I mean the bundle model, all of us have used it because I use it for my PhD as well, but it was a different context. It was curbside management for last mile deliveries. So I use it for explaining the system data, and it was, I see that in Sweden is kind of a popular model, or in the research and literature is quite prominent. And I know that Sarah has used the model as well in other projects.
I would also say that it worked well in the internal discussions. We had like this little subgroup where we had all the discussions. And not everybody are academics, but also the people who were more have a high degree of practical experience had seen the Vandal model before, so it made it helped with the discussions.
Yeah, I don't know really why we ended up with using it.
Yeah, I think that kind of similar, like because it was very nice model that all of the people in the field know it, like in the logistics, and then we have added system dynamics on the top of it, I would say. So we had a background, or like because our goal was like to introduce system dynamic to the logistician people, and then they know already the Vandal, so if we add something else, they can accept it easily.
Yeah, and I guess that's sorry.
No, you just finish your sentence.
Yeah, I think my second question was then, so why did you go for system dynamics?
That's a good question. Yes, I mean I had it in my background. I took courses. I am originally from Colombia, so in Colombia there was a group also working in system dynamics, but I never used it in research as such. So I knew about the existence of the tool, and then when I joined RISE, and then we talked with Sarah, and Sarah told me we have this working package in the project that is called System Perspective, and then she told me, and we have all this information. So I used to work also with quantitative research, like modeling, simulation, and so on. So I said, what to do here? I mean, how to organize and structure the data that we have, and the interviews. The data there was rich and great notes and the diversity of perspectives and so on. So that's why I connected and clicked and said, okay, with this knowledge that I had, like at least basic, and now with all this rich data, maybe we can try to connect the variables and put it in a structured way to present the system perspective that we promise in the project application. So maybe you, Sarah, could talk.
I think for me, I was concerned at the start because it was we have so much qualitative data, and I was worried that we wouldn't would this need more quantitative for it to make sense. But through the guidance, I've understood that it helps me make sense of things and structure things. So I grew into to liking it, I guess.
Yeah, transferring to system dynamics. Yeah, cool. Thanks.
Okay, I've got two questions. The first one is a very specific one. In Central Europe, one issue is about reliability and availability of waterway transport with increasing heat waves or extreme events. Was that an issue that came up, or was it under services? Because I didn't see it. There was just one question. The other is a bit thinking forward, because one of the things we do is kind of transport modeling and forecasts, and we always put this down to, I don't know, 3 components: time, cost, and maybe reliability and budget and cost again. We just did a stated choice experiment, discrete choice experiment, also with the choice of transport mode in freight transport, and it just didn't work, you must say, because there are so few decision makers compared to passenger transport, but an overall choice model has a bit of problems. And is that something also, I mean, when I look at your leverage points, etc., there are few which are directly transferable into these kind of standard parameters. Time, cost. I didn't even see time, travel time, that much. So
Was associated to the efficiency
Yeah.
and the service level.
if you said, if you could give us a tip for modeling, so how can we capture this in a kind of a choice decision? If decision makers are given the choice and we want to increase inland waterway for a forecast, so what are the key parameters that you would identify?
Yeah. I think that it also depends on how the research is designed in terms of the perspective that you are taking. Like here we had different actors, so it's not the choice of one actor, but it's also how they relate to each other. And so if we stand on the side of the shipper, surely then the modeling of the transport choice could help us, and we can collect the data. Okay, how they made the decision about the times that they need, the times that they got offered, this cost and service, and model that transport choice. But then we have here the data also from the shippers, and then the choice in their case is basically in the contract negotiation. Should I do it the service or not? Should I promise this service or not? Or what are the risk based on the balance in the flows and so on. Then you go to the and so on. So that would be interesting to see how to combine the perspective of the stakeholders in a model, in a discrete model.
Or a choice, or let's say a forecast model.
Or forecast model, yeah.
That could be good.
Can I ask
Oh.
if it's okay? So what Juan Pablo is saying is that we have a lot of different stakeholder perspectives here. So when you talk about a choice model, from the choice of from what perspective is it okay to have multiple perspective, or do you think of a particular perspective?
It's a good question. When we do forecasts, we just pretend somebody is making the choice without saying who is making the choice. The problem when we did the survey was to find the people who made the choices in freight transport, because the other problem, of course, in Austria was we don't have a lot of inland waterway transport. So we were given the task to find at least 50 interviewees, but there are only 30 companies were doing inland waterway shipping. So there seems to be kind of a very, in comparison to passenger transport, there's a small number of people making these choices, and the individual has a much higher weight than in passenger transport, which makes the forecast a lot more difficult. So maybe there's something to learn then from freight modeling. We have to do it in a different way. So I was just thinking about it's an interesting thing to say. Maybe it's not the shipper alone. You have to model it.
Yeah, but I think the initial thing would be to say that the transport buying company would be like making the choice. But then, as Juan Pablo mentioned here, it's also like, but what is offered? So it's like, so they would say, well, they don't offer. What are they offering? And what is what's and it's what's offered also part of if the choice is made. Yeah, so there was I find it quite complex. But it's good.
We've got time for two questions, Amir, and then Keith.
Thank you so very much. I'm wondering about the interface points, because for me interface is like a point to which two systems, two subjects, two objects kind of talk to each other, meet with each other, or interact with each other. So with the interfaces, you listed a lot of interfaces in your research. So some of them, to me, did not like interface per se, but maybe I'm taking it too literally. Those interfaces in mind, for example, V2G technologies, there are interfaces for me because automobile industry and the grid system, they are talking to each other through V2G, or charging points, for example, with the grid and automobile industry. So with interfaces, of course, interfaces can be technological, can be institutional, they can be knowledge point we can be actors, intermediators. And the other thing is that it would be interesting to also, beside leverage points, you look at the tipping points, especially social tipping points, and cascades of those social tipping points and the threshold kind of points, and how those leverage points get the system to those thresholds that once passed, the system irreversibly kind of, go forward, accelerate. So that would be interesting in your research. And also, as Anna said, if diagram, if all those leverage points, where they are happening, is that in the interface part or in the layers? So it would be really communicative for the audience.
Thank you very much for your comment. And yeah, I would like to learn about tipping points because I don't know about it, but it sounds very interesting and definitely something that we can explore. And regarding the interfaces, is the terminology of the Wandel model. Is that for the layers you need kind of an interface that connects the actors with the actual transport operation, which is the service market, and then the transport with the infrastructure, which is the traffic and the rules that you have for doing it. So when we refer to interface, is the terminology of the system structure that Wandel uses for connecting the layers. But yeah, maybe.
It doesn't matter if it's technology, it's institution, it's infrastructure, I mean the nature of the interface. So
Yeah.
it could be actors, could be institutions, could be technology or
Yeah,
artifacts
exactly.
or knowledge.
Everything that enables the connection between the layers. It could be actors, it could be services, it could be technologies, it could be, yeah.
I think that maybe last question.
Yeah.
We need
last
to move
question.
on.
I'm very short, hopefully. Thank you for your presentation, quite very interesting, and I think you use system dynamics in a very right way here. I was just wondering, you started with 3 barriers, so business models, technology, and something else.
Yes, yeah.
And now you go with 3 leverage points, which are,
Yeah.
I guess, important factors for success, but also maybe barriers. Or just wondering how this connects back to the initial barriers you identified at first.
Mm-hmm.
So how these 3 barriers go through your whole research, basically.
Mm-hmm. Yeah, that was the starting point, and we coded the data initially based on those. What was related to green technologies. Actually, how we started was with the SWOT analysis. So the SWOT analysis for green technology, SWOT analysis for behavior, SWOT analysis, and so I will say that as of now, that helped us to identify the variables. But maybe we need to elaborate further later on how to get back to those elements and say, okay, this is, or how these leverage points are connected to green technologies, or to, because maybe we missed that connection at the end, and that would be a good way to improve the discussion part and the implication of the results, going back to these 3 elements, because we missed that part in the
Thank you.
Now we have to do a quick handover to Ben. Who's going to talk about bicycle helmet laws.
People online, if you have any questions, feel free to put in the chat or raise your hand.
Pass me a spare chair. I'll put one up here for the victims of the interrogations.
All this time. What is it? Back to the future.
I'm a fencer. I need a sword.
Sorry, just a second. I just have to move it here.
I guess I'll just start. When I went to grad school, I at some point started, it was in Boulder, Colorado, I started biking everywhere. And I noticed that it revolutionized my life. I stopped using my car. The biking got me back in shape. It cured my depression. It was just amazing. I looked forward to my commute. Then I went for a postdoc in Boston, Massachusetts, and I biked for about 3 months. And then I quit. It was just not inviting. It was, I'd arrive scared and angry. And so I stopped biking, but I got really interested in these 2 kind of urban trajectories. One towards a place where bicycling is really inviting.
Thank you.
And one towards cities where it's really there's this sort of an antagonistic feeling between cars and bikes and other modes. And I will, yeah, I'll jump in with this. Oh wait, what's going on? No, I've lost the slide on the computer.
Sorry, folks. How do I fix that? Ah, there. Oops. Oops.
If the arrows work.
Yeah, now they do.
That's the
Now
best.
they do.
Sure, thank you. Also, I grew up in a small town in Nova Scotia, Halifax. Canada has laws that force you to wear bicycle helmets. And this has been very controversial. I started wondering how that influences the development of cities towards more bicycle friendliness or less. And this has become very topical because a lot of countries, even in Europe, are now considering making laws surrounding helmets. Would this help? Would this not help? So I got very interested in the possible ramifications. I'm going to start with saying, on the left, I really feel that all policy is geared towards optimizing well-being, or should be geared towards optimizing an intrinsic good, something that you care about for its own sake. So I have this over here on the left where it's prominent. Problem is, it's hard to measure that. So we have all these correlates from like quality adjusted life years, sustainable development goals, and so on. I'm just going to be looking at lifespan, not because it's the best, but because the data are really good. Now, how do you get lifespan, or really any of these? I'm going to be looking at the most prominent health intervention is an active lifestyle. That's just absolutely huge. Because this is a transportation talk, bicycle helmet specifically, so obviously mobility safety will come up. Clean air is cool to kind of look at. I'm not going to be touching all of these other co-benefits of active mobility, but I just want to note that they exist. That's my contrast with transition to electric cars and also decommissioning the internal combustion engine cars. Notice that if you do everything right, you get maybe a couple of these co-benefits, but you lose most of them. I'm not going to dwell on that. So back to active mobility, mostly biking. When I say the biggest health intervention is active lifestyle, this is a graph showing leisure time, because that's what's studied, physical activity, hazard ratio, all causes mortality. This is not 0, this is 0.5. If you go from an inactive lifestyle to a little bit of exercise, you see a dramatic health increase. Almost just pretty much every disease is affected. An interesting point to note is that if you do a typical amount of commuting, if you do most of it by bike, that lands you right kind of in this neighborhood where you're seeing about a 30% decrease in all causes mortality, basically for free. I am going to be also leaning heavily on something called the safety in numbers effect. I don't want you to look at the math or the dots, except to say that this is a fairly well-studied phenomenon. This is from a meta-study. Each of these dots is a measurement of the parameter of how big the effect size is of the safety in numbers effect. It's well known, it's robust. There is variability, but it's a really cool, interesting effect. The upshot is when you double the number of cyclists in a city, biking becomes about 35 to 40% safer per trip or per distance. Helmets, greater crash survivability. They turn fatal collisions into non-fatal collisions. The effect size is widely debated. So I'm going to assume that helmets are perfect, that they prevent 100% of brain and head mortality. Helmet laws have another effect, which is they reduce biking some amount. There are a wide number of estimates of this, from 5 to 40% among bicycle owners. It seems to be on the lower end of that, probably. We're not really sure. In bike share systems, though, the number's much higher. So we'll get back into that. Now, I'm going to also, I'm presenting not a predictive, but rather an insight model. It's simple enough that I'm going to try to actually walk you through the whole CLD, because it allows me to display my thinking where I get the references that connect each of these dots. So, as bicycling increases, risk decreases, the safety in numbers effect. Conversely, cyclists respond to the risk environment. If bicycling is safer, more people will bike. So you have a reinforcing feedback loop here. This is, again, both of these sides are pretty well studied. Now, as risk goes up, fatal collisions go up, which decreases life expectancy. As trips made by bicycle go up, that impacts disease, which increases life expectancy. Now, how about a helmet law? Well, the goal is to turn fatal collisions into non-fatal collisions, which increases life expectancy. There's another thing helmet laws do, which is that they affect trips made by bicycle, which decreases life expectancy. So you have these two, I'm not a good fencer anymore. So you have these two conflicting things going on, two conflicting points of activation of this policy. Now, so what would Professor Meadows say about this? Well, you've got a reinforcing feedback, an amplifier, and you have a policy, a knob, that affects one of the output variables of the amplifier and also affects the gain inside the amplifier. So, which is, you kind of already see where this is going to go. I'm going to show you a couple more feedback loops here. So this is what I just had. The safety in numbers feedback loop. I've slightly relabeled things and made some room. I also promised you, get rid of that. I also promised you one more thing, which is pollution. Bike trips do compete with car trips, according to at least a few studies. They also compete with public transport trips, but there is a link here. And car trips cause pollution, so you can add that to the health model. Effect sizes. This is fun. So we talked about an hour of biking. You actually get back about 3 hours of life expectancy. So if you bike for an hour, you actually arrive at your destination biologically younger than when you left. You have gained back time. No, you can run the numbers on this. It's really cool. In contrast, I've got fatal collisions. That costs between 1 and 15 minutes per hour of bicycling, depending on environment and so on. Pollution has an asterisk because this is, I'm assuming, an hour of biking per day-ish. If you live in a city with a standard pollution environment, you might lose like a few minutes to 20-ish minutes of life expectancy per day of living in the city, breathing the air. Depending on, there's such a huge variety there, but that's the ballpark. So note that, that number is kind of important. So here's my health model: helmet law enforcement, working on collisions, working on deterrence, bike trips. Another loop, infrastructure, bike lanes, parking, showers, and so on. More bike lanes. Invite more people to bike. More people biking create more policy incentive to create more infrastructure. But the really interesting part here is bike share, which is just like infrastructure. More biking means more demand for bike share, means more investment in it, and so on, which invites more people to bike. But who carries a helmet not knowing that they're going to hop on a bike share? So this effect, the deterrent effect, is actually much bigger in the bike share activity than in just the bikes activity. And I'm going to show you a little more on that. So I said I'm thinking in terms of how many minutes per day do you gain or lose by your activities, by your choice of activities. So my time series here, this is, take the time scale with a grain of salt. But on the y-axis, I have minutes per day of how much do you gain or lose just by living in a city. This graph, mostly I just want to show you that you can kind of look at, do you just look at the safety in numbers effect? it has a very small self-reinforcing effect if you look at any combination of these three feedback loops. If you add them together, safety in numbers, infrastructure, bike share, they combine nonlinearly, which you'd expect, but you know, they do. And as you saw 3 reinforcing loops, no balancing loops. What do you expect? A system that is bistable. And sure enough, we see this depending on the starting point where you initialize your model. The system will converge more and more bike friendly or more and more bike hostile. And I'm going to come back to asking for your help figuring out what the balancing loops are. But this is pretty astounding how, like, the more biking, and vice versa. And you can plot kind of attractor spaces if you want. You can look at over here. I'm saying there are a couple of different parameters. This is how much infrastructure investment you get per person per new cyclist, and how much the helmets deter, how much enforcement you have. And you can plot, you know, these cool spaces of how much, again, life minutes per day you get by living in the city, depending on how you set up these parameters. And what the thing to note here is this cliff. So you have the region in parameter space that converges to a bike-friendly or bike-hostile environment with an abrupt transition. And you can write an optimizer and compute, like, how much of this parameter do you need in order to stay on the good side of the attractor space. But I'm not going to get into that. When you introduce a helmet law, again, I have a time series with minutes per day over here. When you introduce a helmet law, you will see some decrease in the number of bicycling deaths, which, sorry, this is very small. If you have, you know, the more compliance you have, the more people start wearing a helmet, the fewer bicycling deaths you have. So the deaths will, sorry, this should go toward, okay, sorry. This is, yeah, the number of deaths decreases, but then you have these feedback loops activating. You get less investment in infrastructure, less investment in bike share, fewer people biking, and due to just the safety in numbers effect, with fewer people biking becomes more dangerous. So the number of bicycling deaths starts to rebound. It's a classic rebound. You see an improvement and then things get worse. I've also given you magical helmets. These keep you from dying of any bike-related injury at all, including torso injuries and so on. And of course that drops bicycling deaths to 0 perfectly. But if you look at all-causes mortality, introduce a helmet law, fewer people biking, which means less health gain from biking, less health gain from reducing pollution. And in fact, the 100% and the magical helmets with 100% are so close to the same performance that I should have, they both appear, the non-magical helmets and the magical helmets behave about the same, because the difference is so small in preventing fatalities, but so large in preventing diseases, the health effects of bicycle. I'm not going to show you that. That is in case anyone has questions about it. So a little bit of data. This is Cambridge, Massachusetts. A bunch of different data sources. I've got 2 different kinds of manual counts. Thank you. 8 minutes?
5.
5, okay. I've got an automatic count, but mostly the most interesting thing is the use of bike share in green here, how many bike share trips there are. Bike share stations is in the blue line, and how many roads are treated in any way at all for bicycles, the red line. And you can see all these things kind of increase in parallel. As you'd expect, they're all interacting with each other. The manual counts and the automatic counts are kind of weird. I have some ideas about that, but the bike share counts are pretty reliable for measuring bike share use. So let's use that. No helmet law in fake Cambridge. In Brisbane, there is a point 8 is like fairly well enforced bike helmet law, fairly rigorously enforced. Similar number of bike lanes per road, actually more bike share stations. And you see this very interesting increase in Brisbane and then a collapse. Now what happened here, this is actually pre-pandemic, but at some point the bike share, like Brisbane just stopped, people stopped biking there. And the system went into a death spiral. So why? Here are just some more examples. I've got Boston, New York, Washington, all no bike helmet law, and all have this kind of fairly reliable, there was COVID, increase in bicycling versus places with a bike helmet law where you get this maybe a little increase and then a collapse. The system just goes into the bike hostile mode for some reason. So you recall I said that helmet law deterrence affects bike trips, but it affects bike share use more. I've recolor coded, blue is bike share, red is all bike trips. Here on the x-axis I have how rigorously is a helmet law enforced. All the cities I could get data on. Y-axis is how much per year does biking increase or decrease. 0 is no change. And you can see that for all bike counters, for everything except bike share, maybe, here you see it, more enforcement means slightly more degrowth of bicycling. But if you look at bike share trips specifically, pre-COVID, COVID, and post-COVID, for all the data I have, you see this really quite steep decrease in biking the more enforcement you have. So this is, I believe, the first quantitative data showing that that greater bike helmet enforcement really cuts back, really hurts bike sharing. All the previous studies I've seen have been qualitative. So then I wanted to look at a place, I had the speculation that helmet promotion campaigns, we're a socially motivated species, we are subject to peer pressure. What happens if instead of a helmet law, you have education campaigns or social pressure to wear a helmet? If you tell people you really should wear a helmet. Well, Norway does this. They have really rigorous public safety campaigns saying you really should wear a helmet. It's not required, but please do. You're crazy not to. And hey, here are the data sets. And I said, okay, take them out of the data, but then let's see if we can infer to what extent they look like they have a bike helmet law under the my time conditions. Oh, thank you. And okay, so Bergen and Oslo, I see they behave from, take it with a grain of salt, but they all behave as if they have a moderately enforced helmet law. And that's just from promotion campaigns. Anyway, so in summary, yes, helmet laws with perfect helmets increase safety by, about a quarter, which is the number of head injuries, fatalities. Increase your lifetime life expectancy by a few weeks, but they discourage cycling. If you, in contrast, make sure you do everything you can do to encourage cycling, you can increase safety through the safety in numbers effect by factors easily more than 10 compared to 1 1/4. Rather than a 1 to 6 week increase in life expectancy, you get 2 to 5 years easily. And all those other benefits I talked about at the beginning. So, treat helmet policies with extreme caution. Thank you. Yes.
Just, I know you're looking at life expectancy, but how do you value when somebody has a fatality age 22, say, from falling off a bike without a helmet versus the 2 to 5 years that you add to general life expectancy?
I look at the average life expectancy, so I say someone who's 22 could have lived to 83, so you lose 61 years for that person. The average age of a bike fatality in Europe is 54-year-olds are the mean age of death, so that's my mean life expectancy loss. But I treat it all as averages. population-wide.
To what extent do the relationship change if you look at electric bikes? Because the health benefits are lower and the risk is higher.
Yes, I haven't. The data I've looked at here are just lump all the bike share trips together, and more e-bikes are appearing in those data sets. So the health benefit is less. The e-bikes, you know, the Marchetti constant, we tend towards an hour or 70 minutes of mobility per day, just generally. E-bikes, as with all forms of transportation, if you give people something faster, they tend to just go further. The drivetrains where you pedal and it amplifies your force seem, based on a little bit of research I've seen, seem to encourage people to go further and get maybe a little less exercise than on an analog bike, but it's not as big a difference as you'd think. The basically glorified electric motorcycles where you're controlling your speed with your thumb, of course, those are no good. But I have another project that touches on this.
In Austria, discussing introducing helmets just for these bikes.
I'm myself not in favor of biking. I'm more into hiking, but I'm not in favor of any vehicular kind of mode of transportation. But I was wondering with the life expectancy, if it's going to be just walking in the city, you know, just walking, how would it be different? And the other thing is that, what about the motorbikes? So what's the learning lesson from the motorbikes? Because they introduce helmets right earlier, right, with the motorbikes. And the third one would be with Oslo or Norway, maybe the role of scooters, because it's a city with a lot of scooters, e-scooters, so that could have a role in that people, for example, it's not just the herding behavior or social acceptance of using helmets.
Yeah.
So that could be a less of a role than scooters, because when you have scooters, and there is an argument that why should you not wear helmets when you're using scooters and they are kind of faster? But people only think about motorbikes or bikes, and push bikes are not. You're not going that fast. But scooters, you're just accelerating.
I have a whole other project on scooters that I didn't have time to tell you about, but we should talk.
Yeah.
For walking tends to be, in terms of metabolic equivalence, people tend to walk at a slightly lower effort level than they tend to bike at, on average. And there's a significant difference, more than was previously thought, between moderate activity from walking and slightly more straying into the more intense activity that you're encouraged to do on a bike. But you also get more core exercise, walking, more balance exercise. It's different. For metabolic health, I think walking doesn't tend to be quite as good. But there's a lot more to be said there, I think. And sorry, what was your middle one?
With the, learning lesson from the helmet law, because it was, maybe it has been introduced or was introduced earlier, or the motorbikes, and the other one was with the scooters, the role of scooters in not using bikes more often.
The scooters we have to talk about. I think there's a really interesting thing where scooters also create demand for lightweight transportation infrastructure, so I think they may actually play into the feedback loop for creating a more welcoming environment for bikes if their speed limit is low enough. If the speed limit is too high, they scare people away from biking, especially children or vulnerable cyclists. So there's a lot there. I'd love to talk about it. Sorry.
Sorry, I need to read one relevant question from the chat. Gillian said that if I recall correctly, you previously worked at the scooter speed regulation.
Yeah.
It's also harmful for scooter adoption. Are you considering doing a meta study combining with this study?
Yeah, yeah, but not. I haven't made any progress on that yet.
Okay.
But no. Hi, Jillian.
Okay.
I would love to. Yeah, I think that's really important.
And Paul has an article for you on the relevant things, so I
fantastic.
can send it to you afterwards.
Thank you.
Yeah, thank you. It was super interesting. I was just thinking, do you think there'd be an opportunity to break the model down by different kind of trips? In terms of what I've seen anecdotally, these bike share bikes are used in mostly very different kind of urban environments and different kinds of trips than you use your own bike with your helmet for commuting.
Yeah, and actually
They
there's...
don't influence the results in a way.
It does. Where's the best slide for that? So in these are probably mostly counts of commuters based on time. Actually, I'll show you. Do I have one? There are surveys of specific to absolutely only commuters. They show very different shapes, especially a big drop after COVID because a lot of people started working from home. But that effect is receding, and we don't really have the data as it recedes. From the health point of view, of course, it doesn't matter too much unless people are putting less effort in when they're headed to work that they don't want to head to. From the point of view of bringing new people into the system, it's huge. I mean, the inflow to the stock of regular cyclists is, new users, children especially, are people learning at age 5 to bike and making a lifelong habit of it. I haven't looked at this really in any formal way, but yeah, I think it's very important.
Thank you.
Hi, thank you for the presentation. So my question is regarding the behavioral considerations you made while coming up with your model. And because I live in a city where they're trying to promote more active mobility, use of bikes, scooters and all of that, but we've seen that there's been more motorization rather than the use of bikes. So what are some behavioral considerations you had in your model that beyond, the implementation of helmet laws, that influenced your results?
So wait, specifically?
Because you had a comparison between using bikes and car trips as well.
Yeah.
So what were some of the behavioral considerations you considered for bike users, apart from health, which is, the well-being, which is what basically what you're considering?
Oh, what motivates people to switch from car to bike?
Yeah, exactly.
So there's actually a really recent paper great review, I can't remember the authors, that talks about getting people to move from car to bike. Inviting people to bike doesn't really work. You have to use both a carrot and a stick. You have to disincentivize car use through, we have now some people working on road use charges in New York famously, and I think those happen a lot in Europe. Parking restrictions happen all over cities in Europe, even some in North America now. There are, of course, financial incentives. The more rush hour you have. In my model, I didn't show you this part. One balancing loop is, as car traffic increases, it sucks to be stuck in car traffic, so people will tend to bike more, except that people stuck in car traffic tend to be angry drivers, and that makes cycling less appealing. So there's a lot there. I didn't dig into it here very much. Do you have any favorite things that you...
Oh, no, I was just curious to know more about the behavioral considerations you considered, because we know that regulations alone cannot influence behavior, so it's important to really make this very clear. Yeah. And also considering things like city geography, they consider it, because I think smaller cities, you basically have more incentive to bike more than in bigger cities. For instance, Canada, US, you have more cars than bikes.
Yeah.
Yes. So
especially when
demographics, things like that.
The urban sprawl areas, like in western cities in the US, they're huge, long streets, suburbs that go on for miles, and it's much harder to implement any sort of infrastructure, but the distances are longer. That's a really good case study for e-bikes, at least.
One last question.
Oh, you already got 3. You haven't got any.
Last question.
Yeah, thanks for the presentation. I'm very happy to hear that there is a presentation about bike helmets saying not necessarily we need more bike helmets, so thank you for that. But my question is also regarding behavior. Did you study the phenomenon that a more safe system could actually lead to less safe behavior? For example, with a bike helmet, I dare to bike faster, which could be more or less safe. Or did you find that it's not important effect?
I haven't found anything on the topic. This is broadly called risk compensation, and it's widely studied not just in biking, in many domains. My impression is that it's a transient effect. If you go from biking with a helmet to biking without a helmet, you will start by being a little more cautious, but then you maybe kind of revert. But that's based on kind of my own feeling about it, so don't take that with a grain of salt. Risk compensation is real, and I haven't incorporated it in my model in any way at all here. But I'd like to.
Thank you.
Any more online before we break?
No.
Okay.
Yeah, well done. Yeah, and I really love that you have adopted this atmosphere of asking questions. So I continue with that. But now let's get fueled by some coffee. So it's coffee outside, right?
Yeah. And kanelbulle.
And kanelbulle. Yeah.
Can explain
So
what
that's
is it?
nice.
It's a Swedish. So it's
And then we start again at 11. So please be here a few minutes before that.